When numbers are in Surds form, we need to make the number in the square root as simple as possible. Example, square root of 48. So to make this, we need to think of the factors of 48, which is 1 must be the biggest square number. So we have factors of 48, which 1 is a square number, means 16 and 3. So 16 is a square number, while 3 can be multiplied to 16 will give us 48. So that means we have square root of 16 times 3. Then multiplying surds, we have square root of 16 times square root of 3, which is equal to the square root of 16 is 4 times the square root of 3, which is 4 times the square root of 3. So we have simplified the square root of 48 into 4 times square root of 3. Now, let's try answering these 3 questions that are surds that I have. Let's simplify this. So first one, we have square root of 32. Now, for square root of 32 or 32 with, factors of 32, which one is a square number, is 16 and the other one is 2. So 16 times 2 is 32. So we have square root of 16 times 2. Then square root of 16 times square root of 2. Then square root of 16 is 4 times square root of 2, which is equal to 4 times square root of 2. So 4 times square root of 2. Okay, let's proceed to the next one. I'm going to use another color. Let's say I have to use red. So we have here 18, square root of 18. Square root of 18. Now, factors of 18, which is 1, is a square number, which is 9 times 2. Okay, so 9 and 2 are factors of 18. So we have square root of 9 times 2. Okay, multiplying surds, square root of 9 times square root of 2. Okay, now square root of 9 is 3 times square root of 2, which is 3 times square root of 2. Okay, that's the simplified way of writing square root of 18. So 3 times square root of 2. Okay, the next one is 72. Okay, square root of 72. Okay, factors of 72, which one is a square, is 36. It's a square number, times 2 is 72. That's correct. So, okay, square root of 36 times 2, then multiplying surds, square root of 36 times square root of 2, then square root of 36 is 6 times square root of 2, then we have 6 times square root of 2. So the simplified way of writing square root of 72 is square root of 6 times square root of 2. Now, we will use FOIL method to expand this equation. Okay, so we have open bracket, square root of 3 minus 2, close bracket, and then times open bracket, square root of 3 plus 4, close bracket. So using FOIL method, or the FOIL means F for first, O for outside, I for inside, and L for last. Okay, so first, let's have the F. Okay, the first, so we have to multiply root of 3 times root of 3. So we have root of 3 times root of 3. Okay, then let's proceed to outside. Now, root of 3 times positive 4 is positive 4 times root of 3. Okay. Then let's proceed to the inside. Negative 2 times root of 3 is negative 2 times root of 3. Okay. And then the last one is negative 2 times positive 4 is negative 8. Okay, then let's tidy up. We can see that these two here are like terms. Okay, so we have root of, okay, we learned earlier, okay, in our previous lesson that when we multiply, when we have root of 3 square, will give us the original number 3. When we multiply um, root of 5, okay, times root of 5 or root of 5 squared will give us the same number as original, which is 5. In other words, if I have root of a times root of a will give us a. Okay, this one is in our previous lesson. So therefore, this root of 3 times root of 3 will give us 3. And then adding like terms, positive 4, negative 2 means positive 2. And then copy root of 3. And then minus 8. Okay, then let's continue tidying up. We have here 3 and negative 8 will give us negative 5 plus 2 root of 3. And that is our final answer. Okay, let's proceed to the next one. Okay, I have here two questions which we need to simplify. So let's do the first one. Now, root of 2 plus 2, close bracket, times root of 2 plus 5, close bracket. Okay, using FOIL. Root of 2 times root of 2 will give us root of 2 times root of 2. Okay, and then we have the outside. Root of 2 times positive 5 is positive 5 times root of 2. Okay, the inside, 2 times root of 2 will be positive 2 times root of 2. And then the last is positive 2 times positive 5 gives us positive 10. Okay. Now let's tidy up. Okay. So root of 2 squared is 2. And then combine this like term plus 7 root of 2 plus 10. Then combine this 2 and 10 makes 12 plus 7 root of 2. So that is the answer for the first one. So we have 12 plus 7 root of 2. Okay, let's proceed to the next one. I need to copy open bracket 6 plus root of 5 close bracket times 2 minus root of 5 equals, okay, using the FOIL, 6 times 2 is 12, okay, and then 6 times negative root of 5 is negative 6 times root of 5. Okay, and then inside root of 5 times 2 is 2 times root of 5. And then the last positive root of 5 times negative root of 5 will be negative root of 5 times root of 5. Okay, now let's tidy up. Okay, we can see here like terms. So we have 12 and then negative 6 plus 2 is negative 4 and then root of 5. And then this one is 5. Root of 5 squared will give us 5 and then negative. Okay, then combine 2 and negative 5 will give us 7 minus 4 root of 5. Okay, so our answer here is 7 minus 4 root of 5. 7 minus 4 root of 5 times root of 5. Now, let us use the FOIL method to expand this expression. Ooh, okay, so we have 4 minus root of 3 times 3 plus root of 2. Okay, so let's multiply using the FOIL method. 4 times 3 is 12. And then 4 times positive root of 2 is positive 4 root of 2. Now, inside negative root of 3 times 3 is negative 3 root of 3. And the last, negative root of 3 times positive root of 2 is negative root of 3 times root of 2. Okay, now in this case, we need to, okay, this, we can only perform this one. So we have 12 plus 4 root of 2 minus 3 root of 3 minus root of 6. Now, if you can see, there are 3 surds here. So that means we cannot simplify that already. That means we leave the answer that way. So that's already our final answer. Okay, now let's proceed to the next one. I have, okay, now root of 3 is known to be an irrational number. So irrational numbers are decimal numbers that go forever but never have a repeating pattern. Most square roots are irrational numbers. Okay, there's an exception, and this square root of 9 is equal to 3, and square root of 1.44 is equal to 1.2. These are rational numbers. Okay. So most of the square roots are irrational numbers, but these are not. Square root of 3, square root of 9 is 3, or square root of 1.44 is equal to 1.2. Another square root of 25 is 5. So these are not irrational numbers. There are rational numbers. Now, so we can see here, I have a fraction which is 5 over 5 over root of 3. If you can see, the denominator is a surds or irrational number. And what we need to do is to make it as rational number or rationalizing. We use rationalizing the denominator, making the denominator into a whole number. Okay, now how do we make the denominator root of 3 into a whole number? Remember in our previous lesson that when we multiply, let's say, root of 3 squared will give us the original number, which is 3. Okay, another one. If we have the root of 5 squared will give us 5, the original number 5. That means that if we have root of a squared will give us a. So in other words, to make the denominator 5 over root of 3, the root of 3 into a whole number, we need to multiply the denominators, or the denominator rather, by root of 3 to make the denominator into into a whole number. So whatever we do with the denominator, we have also to do it to the numerator. Okay, so that the fraction, it will not change the value of the fraction. So we have to multiply the numerator by root of 3. Or in other words, it's the same as root of 3 over root of 3 is equal to 1. 1 times 5 over root of 3 will give us the same number as 5 over root of 3. We did not change the value. Okay? Now, let's continue. So that means that if we multiply the numerators, or the numerator rather, so this is 5 times root of, we have it, 5 times root of 3 over denominator, root of 3 times root of 3 or root of 3 squared. Okay, so I'll go here, equals, okay, multiply the numerator, 5 times root of 3 will give us 5 root of 3 over, okay, now, root of 3 squared is equal to 3. It will go back to the original number. Okay, how can we make the bottom of this fraction a whole number? So the fraction is 7 over 4 plus the root of 2. So in this case, we need to use the difference of two squares, or DOTS. So in other words, 4 plus the root of 2, we will multiply it with 4 minus root of 2. So therefore, we are going to multiply the denominator by 4 minus root of 2. Whatever we do with the denominator, we also have to do it to the numerator. So we multiply also with 4 minus root of 2. Then let's rewrite it here. So we have 7 times 4 minus root of 2. And then the denominator, we have 4 plus root of 2 times 4 minus root of 2 equals, we have to tidy up the numerator first. 7 times 4 is 28. And then 7 times negative root of 2 is negative 7 root of 2. And then for the denominator, we have to use the FOIL. So 4 times 4 is 16. And then 4 times negative root of 2 is negative 4 root of 2. And then multiply the inside, which is positive root of 2 times 4 is plus 4 root of 2. And then the last, which is positive root of 2 times negative root of 2 is negative root of 2 times root of 2. Okay. Now, for the numerator, we have already tidied up. So we don't need to do anything on it. What we need to do is to tidy up the denominator. So if you can see, I'm going to underline negative 4 times root of 2 plus 4 times root of 2. Okay, this one is similar terms, and this is considered as 0. Okay, so we'll just simply cancel this one, and we have to rewrite 16, and then negative minus root of 2 squared is equal to 2. Okay, let us proceed to, we have 28 minus 7 times root of 2 over 16 minus 2 is 14. Okay, we're almost done. But if you can see, 28, 7, and 14 are divisible by 7 or can be divided by 7. So we can simplify that one. So we have 28 divided by 7 is 4. 7 divided by 7 is 1. So what left is minus the root of 2 over 14 minus, or 14 divided by 7 is 2. And that is our final answer for this. Okay, let's apply now. There are two fractions. Okay, we're going to rationalize the denominators and simplify the fraction. Okay, so the first one, 3 over root of 7. So to make the denominator into 1, multiply it with root of 7. And then whatever you do with the denominator, do it also to the numerator. So multiply this by root of 7. So what we have is 3 times root of 7 over root of 7 squared is equal to 3 times root of 7, and then root of 7 squared is equal to 7. So the answer for this is 3 times root of 7 over 7. Okay, let's proceed to the last one. We have, so this is number 1. Okay, and then let's proceed to number 2. Okay, so we have 7 over 5 minus the root of 7. So to make the denominator into rational number, so we have to use the difference of two squares. So we will multiply the denominator by 5 plus root of 7, which is, that's the same thing we have to do to the numerator. So 5 plus root of 7. Okay, then we have 7 times 5 plus root of 7 over 5 minus root of 7 times 5 plus root of 7. Okay, let's continue here. Okay, now, so I'll tidy up the numerator. So 7 times 5 is 35. And then 7 times root of 5 is positive 7 root of 7. 7 times positive root of 7 is 7 times root of 7. Okay. Then for the denominators, we have to use the FOIL. So 5 times 5 is 25. And then 5 times root of 7 is plus 5 root of 7. And then the inside, we have negative root of 7 times 5 is negative 5 times root of 7. And then the last is negative root of 7 times positive root of 7 is negative root of 7 times root of 7. Okay, now let's continue. So 35 plus 7 root of 7. We don't do anything to the numerator now because it is already simplified, or we have collected them already. Now, for the denominator, we see, I'm going to underline, okay, this like term, and this should be cancelled because this is already 0. Now, we have 25, okay, minus root of 7 squared is equal to 7. So we have 35 plus 7 times root of 7 over 25 minus 7 is 18. So 35, 7, 18, they are already in the simplified one. So that will be our final answer for this. So this one is 35 plus 7 times root of 7 over 18.